Our story begins a long time ago in ancient Greece. There were two philosophers, Aristotle and Democritus, who had different ideas about what matter was made of. Aristotle thought that there were four elements: water, earth, fire, and air. He said that there was a fifth element that was only found in the heavens called quintessence. Democritus thought that matter was composed of tiny spheres that were indivisible. The term atom comes from the Greek word atomos that means uncuttable. Aristotle argued against Democritus's view because it didn't account for boiling and freezing while his did. It also didn't account for divine order or free will. Aristotle's view was much more popular and became very widespread.
This is George Ernst Stahl. He was a German academic who studied chemistry and medicine around 1700. At that time, there was a theory of phlogiston going around. This theory had been around for about 100 years, but this guy was a really big advocate for that theory. Phlogiston is the principle of combustibility. They called it a subtle fluid because it was something that could not be measured but nonetheless existed. This made sense back then because there were other things like light and heat that were also considered subtle fluids. Basically, if you took some wood and burned it, the phlogiston would leave the wood and go into the air. You would be left behind with a pile of ash that weighed less than the original piece of wood. There was a problem when burning metal. The metallic ash left behind would sometimes weigh more than the original metal. This meant phlogiston could have a positive or negative weight. This is Joseph Priestley. He was born in England in 1733. He became a minister in 1755. In his spare time, he would do some experiments with chemistry. He quit the ministry for a time in 1773 after he'd done some experiments with fixed air. Fixed air is what we would call carbon dioxide. Priestley discovered how to make soda water using fixed air. He was given a medal for it by the Royal Society. Priestley did some experiments with fixed air. He placed a mouse in a container with fixed air and another mouse in a separate container with common air. He found the mouse survived longer in the container with common air. This led him to believe that something in the air was used up during respiration that was needed for survival. He did another experiment where he added a plant to both containers. He found that both mice and plants thrived. This led him to believe that the plant was removing phlogiston from the air, making it breathable. He then took mercury calx, heated it up, and trapped the gas. He put that gas in a container with a mouse and found it lived considerably longer than the mice did in the common air container. He proposed the name for this new gas to be called dephlogisticated air. We would call this oxygen. He claimed this new gas was far superior to common air. This guy is Antoine Laurent Lavoisier. He was a French nobleman living at the same time as Joseph Priestley. At that time, Lavoisier was also working on gases.
Priestley had described to Lavoisier a gas he was working on. There was a misunderstanding though because he had described dephlogisticated nitrous air, or what we would call laughing gas or nitrous oxide. This information wouldn't help Lavoisier because he was studying calcination and combustion. This is Carl Scheele. Technically speaking, he discovered oxygen first. However, at that time, Priestley published his work before Scheele, so he got the credit for the discovery of oxygen. A few months later, Lavoisier was also working with mercury calx. He found burning it produced a gas that was much more respirable, combustible, and more pure than common air. He began looking at common air as a mixture of gases, with one of them being responsible for combustion. Lavoisier named this new gas oxygen. Oxygen comes from Greek and stands for acid begetter because at that time he thought all acids had oxygen in them. One of Lavoisier's great achievements was to create a new nomenclature for elements. His list includes the elements of lead, iron, aluminum, oxygen, nitrogen, sulfur, and many more. Lavoisier used a closed system to ensure nothing from the air was reacting with it. He found that the products always weighed the same as the original reactants. This solved the problem of metal ash. He realized the mass was neither created nor destroyed, it only changed. The law of conservation of mass states that for any closed system, the mass of the system must remain constant over time. Or as Lavoisier simply said, input must equal output. The law of conservation of energy says that energy is neither created nor destroyed. Albert Einstein was able to combine the law of conservation of mass with the law of conservation of energy with his new equation. This meant the total amount of mass and energy in the universe is constant.